So we start off with some vocabulary. First, we try to explain what a sequence is here. A sequence is really just an ordered list of items. One way to describe it would be, for example, to just provide the actual list. You could, in fact, just say, "Hey, I've got my list here." Sometimes people use curly brackets to denote sequence. That right there is a list of items, an ordered. You should make a note here, ordered, meaning that the first item. This is often called the first item. Sometimes it's called A0, sometimes it's called A1. The second item is sometimes called A2. The third one is called A3, and you will never guess what they call the fourth item. I know, huh? They think about everything, A4. You could also think about them as functions, functions on the natural numbers. So you could, sometimes I like to write A of 1, which is the function, the first item on the function, or whatever the function maps 1 to. This sometimes I like to call A2. Sometimes the notation makes it more clear what we're doing when you use function notation. But traditionally, a lot of people use these subscript notation. They mean the same thing. It means when you plug into or when you get the second item on the list. Okay, this is a famous example of a sequence. It's just an ordered list. The first item is 0, the second item is 2, etc. Often these dots are used to represent a pattern that's supposed to be recognizable from the first few items. So the pattern implies here, the dots imply that this goes on forever and ever and ever. Okay? That was pretty easy. Again, I'm just assuming that you've seen this stuff before. Some other calculus class or pre-calc class. Another way to describe a sequence would be to give a closed form. Now this sounds like a fancy idea, but really all it is just, it means that a nice formula where you give n is given, and then the formula an is also given, and then you can obtain the next term, an. So here the formula is given like this. An is 2 times n minus 2. So for example, let's just do a little here. So for example, if somebody tells you, somebody tells you a of n is equal to 2 times n minus 2, well, what does that mean? It means a of 1 would be equal to 2 times 1 minus 2. All you're doing is plugging in whichever term you want onto the nice formula. That's the closed form. It should be a closed formula, sometimes people call. And so this gives you 2 times 1 is 2, minus 2 is equal to 0. This is telling you that the first item here, A1, is equal to 0. If I wanted 1, 2, 3, 4, the fifth item, A5, maybe I can just plug 5 into my nice formula. A n is equal to 2n minus 2. That's this formula. If I just wanted A5, maybe I can just plug in 5 here. I keep it right on the ball here. We expect to get 8. It'd be 2 times 5 minus 2, which is equal to, of course, 10 minus 2, which is equal to 8. Told you. See why they pay me? So nice formulas, they're called closed forms. They give you any item on the list. It's almost better than the list because it's a generator of the list. It's a template that you can use to get all the items in this. It's very, very much like a function. That's why I often prefer the function notation. You could easily get the 200th term here. The 200th item on the list would be 2 times 200 minus 2, and so on and so forth. Okay? That's not that bad, right? The closed form is really, really nice. It gives, you can generate the list yourself, or any item on there for that matter. You can get the 1000th term. Other ways to describe them would be something like this. Let me see. Let's go to next slide. So other ways to describe them would be something like this. Recursive definition. Recursive, it means that you represent the next item based on the previous one. So the way you read this is like this. The n plus 1 term is equal to the nth term plus 2. Or said differently, you could read it this way. You could say the next term, this is the next, and by next I mean the one after n, because you see it has the subscript n plus 1. The next term is equal to the previous term plus 2. And when they give you the recursive form, it's always important that they give you a starting point, otherwise you'd never know where to start. So a1 is given to be equal to, here I'll use my function notation, a1 is given to be 0. To get an plus 1, all you need to do is take the previous one and add 2 to it. So in other words, to get the a2 term, 2 would mean 1 plus 1, you get a1 plus 2. That is plugging in a 1 wherever you see n, and you get that. So the a2 is equal to a1 plus 2. This tells you that the second term is equal to the first term plus 2. And we agree that the first term was 0, so this is 0 plus 2. So therefore the second term is equal to 2. Similarly, you can get a3. a3 would be equal to, to get a3 you would need to plug in n is equal to 2 here. So if it's the same thing as a2 plus 1, that makes 3. But writing it this way tells me that my n should be 2. So it becomes a2 plus 2. So the second term we agreed was 2 because we found that out, and then plus 2, that gives you 4. As this one describes exactly the same list as the previous two. The first term is 0, the second term is 2, the third term is 4. What would the fourth term be? According to the recipe again, the fourth term is equal to the third term plus 2, and we've already cut the third term. The third term was 4, so it's 4 plus 2, which of course equals 6. And you can play this game all day long. The fifth term would be the fourth term plus 2, and we had already calculated the fourth term to be 6, so it would be 6 plus 2, which is equal to 8. Again, 1, 2, 3, 4, 5, the fifth term is 8. This describes exactly the same sequence. The recursive form is nice, but it has its drawbacks. Suppose I wanted the 500th term. The recursive form doesn't give me a nice closed form for the 500th term. Instead it tells me, well, go on and find the 499th term and then add 2 to it. Well, yeah, good luck with that. The trouble with that was that you have to find the 499th term. And what do you think the recursive form says about finding the 499th term? It says, well, it's easy. To find the 499th term, you just have to find the 498th term and then add 2 to it. Well, yeah, how am I going to find that? You see, the trouble with the recursive form and the defining feature, as a matter of fact, is that it defines a term using the previous terms as a base. If it uses the previous terms, it's called recursive. And it has its pros and cons. The pros is that a lot of times the pattern is very, very easy to describe based on whatever you do to the previous terms. The bad thing about it is that it makes this finding the arbitrary terms kind of difficult unless you have found all the other ones before that. So it has its pros and cons, and you'll learn more about it as we go on. Anyways, that's what a sequence is. Those are the three famous ways of describing sequence. You can provide a list for people, you can provide a closed form, or you can provide a recursive definition. Alright, let's cut this off here and then come back and talk about another famous word here. The famous word is, or the famous term is called the sequence, limit of a sequence. Come back.